Okay, this is the first example where an airplane is flying towards the east at this particular speed. A wind starts to blow at another direction, that's the north, and with 24 meter per second. We know that the velocity also is a vector quantity. So whether the vector is of velocity or of force, field, anything you see, even displacement, you will have to follow the same procedure. You have to follow those 5 steps in order to get the resultant of two vectors. So in this situation, I'm going to be following 5 steps. First of all, scale down. There is, okay, let me just draw the direction. Never ever smoke weed. So question says that there is 92 meter per second in the east direction, and there is something in the north direction of 24 meter per second. Can you look at the number 92 and 24? It is not possible for me to draw it on the paper, right? So that's where the step one comes in. I need to scale it down, and I need to scale it down in such a way that it can fit onto the paper. Okay, I need to find a scale which can make this accommodate onto a paper. 1 centimeter corresponding to 8 meter per second. Well, by that I know that 24 meter per second will be of length 3 centimeter, I think. Yeah, I think, yeah, 24 is 3. All right, and 92 would be a little bit difficult. 11.5, and I know that 11.5 is a little bit bigger number, but I think that it's very easy to draw a line of 11.5 centimeter on a paper, right? Regular size paper. So that's my first step, where I scaled down the vectors. Now the second step is where I'm going to be arranging them in adjacent sides. So that's my east direction. I'm going to be drawing a length of 11.5 centimeter, and along the north direction I'll be drawing a length or line of 3 centimeter. Okay, let me just do this on a particular screen, construction screen. Okay, this is where I'm going to be doing the geometrical construction. Okay, so I need to draw a length of 11.5 towards the east. Okay, and I need to draw an 11.5 step. Okay, I know that there's the line seems broken, but I think that will serve my purpose. I need to call upon protractor. Let's see if that can help me, because that seems to be out of range. Oh, I cannot do that, right? So all right, since it would be easy for me to do that because it's more like perpendicular line, so it won't be a difficulty. So in north direction, I think I need to draw a line of 3 centimeter, if I'm not wrong. Okay, so 3 centimeter from this end. Okay, that's like almost okay, and we got this as 92 meter per second, and that's 24 meter per second. And well, if you remember, I completed my third step, isn't it? I mean, I completed this third step. Okay, or my bad, I think I completed the second step. Okay, I think I completed the second one. I don't think so. The second one, and the third one states that I need to complete the parallelogram. This will behave like rounder for me. Okay, I will scale. I'll have the scale on my thing. Okay, that seems proper scaling. I'll put it over here. Now I'm gonna be drawing an arc, and I know that the arc will be of 11.5. I'll put this protractor on point on the origin or the starting point, and I'll take the side of this side. I will check if that's correct side, because that's on the that's a little smaller. Okay, I have to draw another arc from this end, and that's completed. And of course, as you might be knowing, that I need to complete a parallelogram. Oh, I don't need this scale, the line, because I think my software can do it properly well. It's that line, and I know that I have to join the other line as well. That's a little awkward. Okay, that completes it. Okay, scale. Okay, that is means I have completed the third step completely. Okay, what is the first step? I think I need to draw the diagonal from this end. So let me just draw the diagonal that starts from here and it goes up to there. As I told you earlier, that this diagonal will be behaving like the resultant of my two vectors, right? So that means now I need to measure the size, because if I don't have that size, I cannot do anything, right? So the stamp tool there, and this 1.7 or 8, 1.8. I'm going to take it as 1.8 because that's somewhere in the middle of 1.7 and 8. Okay, so the resultant size is well, 11.8. Okay, and that's centimeters, so you don't have to get confused. 11.8, that's my fourth step. Are we done yet? I think we need to complete the fifth step, and I think, okay, I'm gonna borrow this number from this picture. Okay, so we completed the second, we completed the third, we completed the fourth. Now we're completing the fifth, where I know that 11.8, I think that was 11.8 centimeter, the length of the diagonal, and I need to convert this into meter per second. I know that 1 centimeter corresponds to 8, so 11.8 centimeter multiplied by 8 will give me, well, it gives me 94.4 meter per second. Okay, so 94.4 meter per second, and that happens to be the resultant. So the resultant for this two would be 94.4 meter per second. It will be a little off from the number because it's not accurately been drawn on the computer screen, right? So if I calculate, the actual value turns out to be 95.1. So yeah, of course there is a little difference, but it's only because the diagram was not okay. It wasn't very accurate on the screen. Okay, this is the first example of finding out the resultant vector of non-parallel vectors. It seems like we're going to have another example where we don't have angle to be 90 degrees exactly, okay? And that would be a little complicated. Well, let's see, have a look at this example. Okay, as you can see, this is the question borrowed from CIE IGCC paper with the year and the question paper and the numbers shown. Okay, this is quite interesting question I found. Okay, the weight of the airliner. Okay, this is the airliner. We're looking at it from behind or something. Okay, say that the weight of the airliner is this much. So when they say that it's the weight, it means automatically it will be acting downwards. There is an aerodynamic lift force of this much. You need to understand that whenever there is a lift acting on the aeroplane, it should always be perpendicular to the plane of the aeroplane. So in this direction, let me just draw it. In this example, the aerodynamic lift will be this. Oh, they say it's 30 degrees to the left of vertical. Okay, so that means it's the vertical, and that's 30 degrees, right? And by drawing a scale diagram or otherwise, so I'll explain you one more method. Show that the resultant of these two forces in the same direction as the resultant force you draw in A. Oh, okay, let me just tell you what A is. This airliner is just taking a turn, and the question A says where exactly the resultant force would be acting. And if you have a little idea about the centripetal force, you're going to find out that in one of my videos related to the forces in motion. We figured out that when a body curves around or moves in a circular fashion, the force acts towards the center. So obviously the force will be acting towards this. So I need to prove that the resultant of the weight of this airliner and of the uplift or the aerodynamic lift comes out to be in this direction. So, well, this is what we have to check. Okay, let's get started right from the first step. Okay, the first step is to scale the thing down. Obviously 1.20 into 10 raised to 6 is a very huge number. Okay, so I'm going to be considering it as, okay, let me just write 1.2 into 10 raised to 6 as 12 into 10 raised to 5. I just shifted the decimal and reduced the number of 0 from that 10. I got this. Okay, if I consider 1 centimeter to be representing 2 into 10 raised to 5. So this would correspond to 6 centimeter and 1.39. Okay, I'm going to be writing this in terms of 10 raised to 5. So this looks like 13.9 into 10 raised to 5, and if I apply this particular scale, I can scale it down to 7 centimeter. So this is trial and error basis. You have to find a good number so that you can put your vectors perfectly and appropriately on your paper. So I scaled it down into two different values. The weight would be 6 centimeter acting downwards, and there is 7 centimeter of the lift which is acting 3 degrees to the left of vertical. That's my vertical direction, and to the left 30 degrees. Did I say 30? Okay, 30 degrees. So that's my uplift. The second step is to draw those vectors in adjacent sides. So that's one of my vector. That's W. That happens to be 6 centimeter the weight, and that's my vertical line. And I'm going to measure 30 degrees from here, and I'll draw an uplift that is of 7 centimeter. Okay, now the third step. Third step is to complete the parallelogram. So I'll be intending to draw 6 centimeter down because that's how it is. Okay, I cannot fit my diagram vertically. I'm going to rotate the entire picture this way. I'll show you. Okay, this is still my second step. Okay, the problem with my construction screen is that I cannot have this idea. So I'm going to do one thing. I'm going to make the 6 centimeter the base so that I can draw the angle of 30 degree. I draw the line, and I can draw a line of 7 centimeter, and then I can complete the parallelogram. A bit of geometry. If this is 30, automatically this angle would be equal to 150. So I'm going to draw this, where 6 centimeters happens to be the base, which is nothing but representing weight. 7 centimeter is the uplift. Okay, so I just rotated it to accommodate it on my construction screen. I will have to inverse it so that I can have 6 centimeter on this side, the way I showed you on the rough diagram. That's my pencil, which can draw me a straight line. 6 centimeter, and I know that that's the weight. Okay, so let me just write that's so 6 centimeter. And okay, now it's time to talk about I need to draw uplift thing. Okay, that's a 30 degree. I marked it. I don't need protractor anymore. I'm gonna have to make it straight at this end, and I need to draw a line which goes through the 7. Oh, my bad. That's it's again kind of stepping out of the screen that is available to me, and this is the line that goes there. Okay, that's my 7 centimeter line. Let me just remove the scale. That's my 7 centimeter. I completed the second step where I actually arranged the vectors at the adjacent side of the parallelogram. Now the third step where I need to complete the parallelogram, I'm going to call in the rounder, fix it over here, take the size of the side. I gotta be careful. Okay, I put it over here. I'm gonna put on this side and I'm gonna draw an arc. Okay, I'll do the same thing. I'm gonna put this end on this particular point, and I'll take the shape of this side. I hope it's on the proper end, and I'm gonna draw the another arc. Okay, so I'm done. I have to draw the sides. I'm done with my second step. The third step is to complete the parallelogram. Okay, so you can see that like this I have completed my parallelogram, and now I have to draw. Okay, if you remember the fourth step, I need to draw a diagonal that starts from starting point of this thing, this vectors, and it's the diagonal that has to go to the other end. And though it is, this is the resultant of both the forces. And if I kind of measure this, because that's what I need eventually, it comes out to be 3.5. So I done the fourth step as well. Okay, so coming back over here, we know we completed the second step, we completed the third and the fourth of constructing the diagonal. We came up with a number which was 3.5 centimeter. Okay, so now if we remember the fifth step, I need to scale this up. 3.5 multiplied by the number that you got over here. We consider this the scale, 2 into 10 raised to 5. That is 7 times 10 raised to 5 Newton. So 7 into 10 raised to 5 Newton is the resultant, it's the magnitude of resultant force, and it would be directed towards the west. Okay, so this is the end of this video, and let me just recap everything that we did in this video. We talked about the different types of quantities in physics, scalars and vectors. We talked about what's the difference between them, and then we talked about what are the two types of vectors that we will be dealing with, and we'll be talking about the mathematics of. And then we first of all was the parallel vectors, which were easy to handle. We add the vectors when they are parallel and in the same direction. We subtract them when they are in opposite direction. Non-parallel vectors, we got the 5 different steps to follow, and we saw few examples of how to find out the resultant vectors of non-parallel vectors. And so we're going to be concluding this vector topic over here with this video. Next time we're going to meet in another video with some other interesting topic of physics. Till then, take care.